Welcome to the third and final video for section 3.3. This is a very short video, but I just didn't have time to do it on the others. We're going to begin with example number 15. Example number 15 is the cosecant to the fourth power of x minus cotangent to the fourth power of x is going to equal the cosecant squared of x plus cotangent squared of x. Now, to me, both of these look pretty much a little or just as difficult as the other, except this one has higher exponents, so let's deal with this. And I realize this is a difference of squares, so I can rewrite this as the cosecant squared of x minus cotangent squared of x times cosecant squared of x plus cotangent squared of x. Now, when I'm looking at where I want to go, I realize I've got this factor right here. So if there's some magical way or some mathematical way to get this to be 1, then we're all good. So I'm going to somehow try and get this to equal 1. Well, cosecant squared of x is, if I would take the identity for cosecant squared of x, that will equal cotangent squared of x plus 1, and we still have to subtract the cotangent squared of x. Now here, remembering that we have to go one step at a time, we have to realize we have 1 times cosecant squared of x, and normally, you know, this would just be, well, let it go. But since we are proving stuff, we need to make sure that we show each and every step. And so we are finally to where we need to be, and so that's exactly what we needed to prove. Finally, example number 16. The sine of x over cosecant x minus 1 plus the sine of x over cosecant x plus 1 has to equal 2 tangent squared of x. Okay, first thing I'm going to do is realize this is the more complex side, so this is where I'm going to start. And I look, okay, cosecant x minus 1, cosecant x plus 1. They're very similar, but realizing that if I get a common denominator, I'm going to get a difference of squares. So I'm going to find the common denominator, and that common denominator will be cosecant x minus 1 times the quantity cosecant x plus 1. And we'll be able to simplify that in just a few minutes. But this will become the sine of x, and then I have to multiply by cosecant x plus 1. And then I'm going to have to add in the sine of x multiplied by the quantity cosecant x minus 1. Okay, I'm going to do the denominator first because it is just a little bit easier. Cosecant x minus 1 times cosecant x plus 1 is cosecant squared x minus 1. So we've got that simplified enough. And then we have to try and simplify these, or to actually FOIL them out. Not FOIL, but distribute them. So we get sine x times cosecant x. Or another way to look at this is the sine of x times 1 over sine x plus 1 plus sine x times 1 over sine x minus 1. So let's see what we get here. Sine x over, or times 1 over sine x is 1. Sine x times 1 is sine x. Sine x times 1 over sine x is 1. Sine x times the negative 1 here is negative sine x. And then we're still left with cosecant squared x minus 1. Okay, the sine x's cancel, leaving 2 over cosecant squared x minus 1. But using the Pythagorean identity, cosecant squared x minus 1 is equal to cotangent squared of x. And 2 over cotangent, well, since cotangent squared is in the denominator, using the reciprocal identity, we get 2 tangent squared of x. And that's exactly what we needed to prove. And therefore, we are finished.